Welcome to Greenplum Summit 2020, the reimagined digital customer conference. My name is Jacques Eistock, and my first guest is Divya Bhargava. Divya is here to talk about expanding the software-defined data center to data. There's no question that the SDDC brought amazing optimizations to the enterprise. So Divya, can you help us understand it and understand how data fits in?
Hey, thank you, Jock. Hi, everyone. As Jock introduced, I am Divya, engineering lead at Greenplum, and I'm glad to be with you all today in this virtual summit. I will be talking about expanding the software-defined data center to data. The software-defined data center is often called SDDC, if you see me using those acronyms at times. Greenplum is now a part of the VMware family. I welcome everyone from the Greenplum community to VMware. Greenplum's mature and robust feature set and VMware's industry-leading virtualization platform make it an unbeatable combination. So VMware started its evolution with software-defined compute. This is where this is more commonly referred to as vSphere, where you have ESXi hypervisors, which take the processor and memory, aggregate them into a pool, and make it available for multiple virtual machines. What this essentially means is to take a single server and run it on run different virtual machines on them. Each virtual machine could have its own operating system. This brings in several advantages like reduced cost. We don't have to spend for the rack space or all the power consumption for the cooling of the systems. It also brings in increased system utilization, easy maintenance, predictable high availability, and also disaster recovery. Most of us still know VMware for this software-defined compute. Over the years, however, VMware has evolved to do much more than the software-defined compute. We now also have software-defined storage called vSAN. This is where we take the commodity hard drives and the commodity flash drives, aggregate them into a pool, and turn them into software-defined SAN. As the business needs change and we need more storage, we can bring in another server and expand the SAN. vSAN comes with several features like deduplication, compression, and many more as listed. I will get into a few details about vSAN because they're quite relevant to Greenplum. So vSAN breaks down the underlying storage into disk groups, and each disk group has a capacity layer and a cache layer. vSAN allows both all flash, which means both capacity and the cache layer are flash devices, and hybrid SAN, where you can just have the cache layer in flash and can still use magnetic disk for capacity layer. All flash is better performant and works really well for both OLTP and OLAP workloads. So this would be our recommendation for Greenplum. With respect to fault tolerance, vSAN comes with different levels of fault tolerance. With RAID 5 or 6, there's also support for deduplication and compression, which need significantly less space for good fault tolerance. vSAN allows you to scale out by adding more servers or scale up by adding more disks. So after achieving the software-defined compute and storage, the next thing to virtualize was the networking and security aspects. This is referred to as the NSX data center. NSX data center takes the features of what is found traditionally in a hardware-based switch and a router and brings those networking features open to the hypervisor. So now with vSphere, vSAN, NSX data center, what this gives you is a software-defined infrastructure. Another term for this, more commonly used by the DevOps people, is infrastructure as code. So what this really means is you can build your infrastructure using scripts, code, blueprints, or any other kinds of automation. At this point, what we need is a way to manage and monitor this platform. This component that's used for managing and monitoring this platform is called the vRealize. It can help with things like deploying new VMs or monitoring the logs, business reports to understand, okay, what's my cost? Uh, some of these things come with vRealize. So what really started as a software-defined server, which is the vSphere, has now evolved to a software-defined data center where you have vSphere, vSAN, vRealize, and NSX. And with this, you can completely grow it even further to actually use any of the clouds, be it a private cloud, a public cloud like AWS or Google, and overall, all these working together, it creates a truly hybrid cloud platform. VMware lets customers pick their deployment model, which could be an appliance, a private cloud, public cloud. So it just makes it really flexible. So what we have now achieved is a hyper-converged infrastructure. I'll just try to explain that term once again. I mean, it's come in as a part of the presentation, but I would emphasize on this. Hyperconverged infrastructure is a software-defined IT infrastructure that virtualizes all the elements of conventional hardware-defined systems. VMware has been a repeated leader for the hyperconverged infrastructure. So to achieve hyperconverged infrastructure, you can start off by having the vSAN and vSphere, and then expanding and build over it to create a full stack and a hybrid cloud eventually. It's easy to ask, does it make sense to have a database in this virtual infrastructure? Is it safe? Does it make it slow? If you go to my next slide, it turns out that databases are perfect candidates to sit on the virtual infrastructure. There was a survey conducted among our vSAN users, and as you see here, the biggest space is occupied by databases. So by using virtualization of databases, we are not only having better management and deployment capabilities, but we can also scale as needed and utilize this system resources efficiently, which also results in better performance. So let's look at software-defined data center for Greenplum. Yes, Greenplum is already running on VMware in several of our customers. Here's a manufacturer use case who have multiple Greenplum clusters, storing several terabytes to petabytes of data. I'll not go through the details of each. These slides would be shared out in the end, so you could dig into these. So Greenplum on VMware software data center will simplify the operations. It will reduce the complexity and allows flexible infrastructure. I will get into some more details on how all these are done, but these are some of the reasons why Greenplum on VMware makes it a great combo. So how do we reduce complexity? The complexity is reduced by allowing rapid deployment of Greenplum instances. You won't have to worry about the low-level OS configuration if you use the VM templates. Day zero operations and provisioning on needs to have like shared or dedicated or elastic resources is much simpler. Day one, day two, day N operations and maintenance also become much simpler. So these are things like hardware failures, firmware upgrade, etc. We don't have to deal with this horrific hardware migration projects because migrating virtual machines from one to another can be achieved quite easily using the vMotion capability, which is another product of the VMware ecosystem. With flexible infrastructure, you can choose where you want to put different workloads. Some of them may make more sense on bare metal, while something else might make more sense on the cloud. Since you have consistent infrastructure from operations standpoint, you can optimize your investments. You can go to market faster and really scale out the MPP with virtualization. So here's a diagram that shows some deployment strategies for Greenplum on VMs. As you can see on the left, you have dedicated host deployments using local storage, which is a common production use case. And on the right-hand side, you see shared host deployment using shared storage, which works well for sandboxing testing environments. In this slide, we have some recommendations for for a small, medium, and large Greenplum deployments. If we dig into one of it, let's say medium, what it takes is 4 physical servers, each physical server breaking out into having 48 to 64 cores per server, and the memory is about 368 to 768 GB. And we have 24 drives, 4 of which is NVMe used for the cache layer that I previously mentioned, and 20 used for the capacity layer. And we have 4 25 gigabyte network interfaces, 2 of which are used for vSAN, and the 2 other used for interconnect, the Greenplum's interconnect. So, and you get the Greenplum database and AI/ML libraries and fast I/O. So this is an example configuration. In conclusion, what we saw today is how we put data in the software-defined data center. The deep analytics and mature features of Greenplum combined with VMware makes it easy to maintain, cut down the costs, and allow a truly hyper-converged infrastructure. Thank you. I hope you enjoyed the session. Thank you.
Thank you so much, Divya. I love hearing the embracement of Greenplum leveraging hyper-converged infrastructure. Obviously, we've had users doing this for a while, but it's something we haven't really been talking about as much. So love the fact that we're doing it. I love how we're thinking about bringing Greenplum and our customers closer to the future of data. So thanks again.
Thank you.